before jumping immediately into the code, we can talk about toggle code in general, and just to get a sense of what we'll be looking at when we're actually walking through the code, is that toggle code is really simple, that there is some event, and say that you have a digital pin like what we're going to do with digital pin 7 on the Arduino, and it's currently set to high, or it's in an on state. Well, then some event occurs, and then it toggles to the off state. Or if it starts out, in our case, digital pin 7 is in the off state, an event occurs, and then it toggles to the on state, back and forth, just like the standard old toggle switch. It's off. The event is the flip of the switch, and then it's in on. Then when a flip event occurs again, and it's back to off, over and over, so that you can toggle back and forth between two, in this case, digital states. You could just as well, though, add a counter in the code and toggle between multiple on and off states. But software is a lot easier to alter, modify, and add all kinds of cool little neat features to than a standard toggle switch is. But toggle code, that's basically all it does, is you have your Arduino listening for some event to occur. You have a variable that is going to be toggled from a high or a low state, and then via that variable you'll toggle a pin state on the Arduino. That's how toggle code works. A way to think about it, in our case, using a sound detector, we're going to have the sound detector basically just listening to the ambient environment, and then when a sound has enough volume or amplitude to cross over a threshold that we will set in the code, then the crossing of that threshold will be our event that will trigger our variable to flip from one of these states to the other over and over and over again. If it starts out with the variable we use, if it's set to 1 at this point, and then a sound, and this is the ambient, no sound, then a snap of the fingers or a clap of the hands occurs, and if that has enough amplitude to cross this threshold we'll set in code, then this 1 on the other side of that event will switch to a 0. And then we could have background noise or could have someone talking. This is why it's important. Where we set this threshold matters, and moreover, this threshold, where you end up setting it, it's going to be sort of relative to the sound detector board you receive. Some of them will be more or less sensitive, and the environment that you put our circuit in may be more or less loud and have more or less background noise. So setting that threshold takes a little work. You have to play with it, doing analog reads, and to determine exactly what's the best threshold to set. We'll look at it in the code in just a second. But say that as it's going along, all of a sudden our sound detector's listening, there was this blurb, but it wasn't of enough amplitude to go past our threshold, so nothing happens. Our variable stays in the 0 position in this case. Then a snap occurs, a little quieter than the one that initially triggered a toggle, but it's enough, given that it goes over the threshold, to flip our variable to a 1. Then another sound occurs that surpasses our threshold that we've set, and this will go back to 0. And that 0 will track over even this ambient background noise until it encounters another event of the sound detector, the voltage signal coming in from the sound detector, which is its representation of the sound in the outside environment. The voltage exceeds this threshold we've set, or the reading exceeds it, and then that's enough to flip it back to the 1 state. And it can hit another one, and it'll go back to the 0 state. On and on and on. It just keeps going. The sound detector has no beginning and end. It's just, you can think of it in this linear line, with this being your audio signal, the sound, or your voltage peaks and valleys, as sound is moves the electronic microphone on the board, and as it jumps past these thresholds, that's what we're going to have our Arduino paying attention to. If the voltage level being sent from the envelope pin of the sound detector exceeds a set threshold we put in the code, then that will toggle a variable in our code, which will in turn toggle the state of that digital pin D7 to on or off. And that's just a quick run through of the sort of idea behind toggle code and how it's going to play out. At this point, let's look at the actual code.
To discuss the code, the first thing you'll need is a few global variables. We have a constant integer type variable. I've labeled it control pin, and this is digital pin 7. This is the pin that's connecting to the positive side of our solid state relay. Then we'll need a variable to track the state of this pin. There's a way to do a digital read and then a digital write where you don't need this extra variable, but to me it's always made the most sense to have a separate variable that's tracking the current state of the control pin, what it was toggled into the last time, and you can initialize that to 0 or in the off position, kind of like you have a toggle switch and it's flipped to off initially. But this variable will track, just as its name implies, the current state either on or off of the control pin, digital pin 7. Then we'll need a constant integer type variable. I've named it analog pin, and that is A1. This pin is connected to the envelope pin of the sound detector, of that SparkFun sound detector. And then the final variable we'll need is the threshold. This is, as that sheet that we just looked at described, that this is the threshold we have to set so that snaps of fingers or claps of hands trigger a toggling of this control pin state variable, and in turn a toggling of a high or low being written to that digital pin. This is the variable and its value that will dictate when that happens and when it doesn't happen. We'll talk in just a second about how to determine what value to assign this particular variable. I've found out through experimenting that a value of 100 works fairly well to be able to snap my fingers and turn on that solid state relay, in turn controlling a lamp. But we'll talk about it some more. And in setup, we have void setup. These are just global variables above void setup. Then we enter void setup and we establish a serial connection, 9600 baud spine. Then we have a brief delay to give that connection enough time to actually establish. And you can comment this part of the code out after you have determined what your threshold value needs to be. But initially you'll need it in there so you can determine the threshold, the value to assign to the threshold variable. We'll also need to put that control pin that is associated with digital pin 7. We need to put it in its output mode, and the analog pin. Arduino pins are in the input mode by default, so declaring it explicitly is not necessary, but once again, normally when you're coding, be as explicit as you can. It's not going to hurt anything to tell the Arduino, okay, yeah, that analog pin, in our case A1, needs to be in the input mode. And that's why this is in setup. It's not absolutely necessary, but it's there, just to be explicit. Moving on to void loop, the first thing we're going to do, or we want the Arduino to do, when it enters void loop, is read the value being sent from the sound detector and collect it off of our analog pin. Remember, it'll be coming in as a value with the analog to digital converter in the Arduino somewhere from 0 to 123. It'll be somewhere in between those, or 124. It'll be somewhere in between those two numbers. And that's what this value will be. Well, we want to read that value and assign it to a new variable that's created, and it's an integer type variable, and we'll just call it analog value. That is the value that's being read off of our analog pin, that's connected to our sound detector. We want to store and hold that value. That's why we need a variable for it. And then initially, we'll want to see what that value is, see what the outside in the ambient environment. And we can do that by serial print, analog value. You can label it whatever you'd like. And then we can serial print the actual analog value. This will just print the words with the equal sign. This will print the actual value behind it just to give us a nice display. And notice the print line is used here so that it tracks vertically rather than having your value shoot off horizontally across the serial monitor screen. Now we enter the actual toggle part of the code. We'll take and use this if control structure. Notice that the if starts here and then it closes down. That's the bottom parentheses right above the end of void loop. What we'll do is say if, or we'll test and compare, say what is our analog value and is it greater than our threshold value, over and over and over, infinitely through void loop. Every time void loop rolls around, that's what it's going to be doing. It's going to say, is the analog value that's being read off of analog pin 1 greater than the threshold value we set up above? If it is, then initially delay for half a second. This delay can be a little less, but you do need a delay in here before you enter into the actual toggling part of the code for stability and also so that it doesn't misfire. Keep in mind that the Arduino is sampling that analog pin thousands of times a second, and that we have a sound detector that has an electronic microphone in it and various op amps and peak detection circuitry. But it is sending a signal fairly quickly, and then the Arduino is reading it super fast, and it's almost like debouncing a button that you only want to catch the moment that the analog value exceeded the threshold, but you don't want to catch all the reverberations of the actual electronic microphone, the diaphragm wiggling back and forth, calming back down to its stable state of no sound. In order to do that, we catch the initial value when it exceeds the threshold and then immediately jump into a half-second delay. That gives the microphone enough time to stabilize back down, rather than if we snapped our fingers, it may exceed our threshold, which in the case of threshold value I'm using is a 100. Well, the snap of the fingers might actually be up there, generate a 200 or 300 on the analog value, and then it has to trickle back down or calm back down before it drops back under that 100 mark. And during the time that it's bouncing and sending out, say if it triggered at a 300, then it'd have a 290, a 170, a 105 until it finally hits the 100. Well, all that bouncing, essentially it's a bounce. All that bouncing would get read, every one of those. And then we would be toggling back and forth for every time that the value exceeded the threshold. But what we want is a clean trigger. We want it to snap our fingers, it toggle to one state, and stay in that state, rather than jumping back and forth between multiple states. In order to do that, a half-second delay works perfectly. But depending on the sound detector you have, you may need a little longer delay. A shorter one would work with the particular board that I have, but in most cases a half second will be plenty long. That's a lifetime as far as a microcontroller is concerned. And it'll make your toggling stable, and it'll inhibit or prevent misfires or multiple on and off toggles. And just to see it on the screen so that we can see it in just a second while we're looking for our threshold, I have these serial print lines. That all of these serial prints, and even establishing that serial connection, can be commented out once you have determined what threshold you need to set the threshold to. But this will give us a long, drawn out, it'll stand out from just the standard printing the analog value. We'll see it in just a second. And then I have a delay in here, which helps us capture and see when our threshold has exceeded on the serial monitor. It just slows things down. You can comment out this delay after you've established your threshold. I'll show at the end of the video how you can do that. At this point, our sound detector is listening to the ambient environment, is reading the analog value coming in on analog pin 1, and suppose it exceeds the threshold. It goes over the 100. At that point, it's going to wait half a second. Then it's going to assign to the control pin the opposite value. Remember, the first time through, when you plug in the Arduino, we've set the control pin state variable to 0. So it's going to say, okay, well, now we want that control pin state variable to be the opposite of whatever it is. Well, if it's 0, this is going to assign a 1 to that variable. So now our control pin state variable would be a 1. Then we could kick into this next embedded if-else control structure. It's inside the overall if structure that it says if the value of that control pin state variable is a 1, then turn the control pin itself, digital pin 7, to high. That will in turn turn on the lamp. Otherwise, if the analog value exceeded the threshold, but the last time it went through, this control pin state variable was set to a 1, this line of code will convert that to a 0, and then it would pick up the else part, turn the control pin to low. And these little lines of code right there are all that it takes to toggle a pin state back and forth on an Arduino based on the occurrence of some external event. This is detecting for the external event, that line of code. If the analog value exceeds the threshold, then do something. Well, what do you do? Well, first, toggle the value of the control pin state variable. If it's a 0, turn it to 1. If it's a 1, turn it to 0. Then test after that. Say, okay, so what is the control pin state variable now after its value has been toggled? If it's toggled to a 1, then turn your control pin on the Arduino, digital pin 7 in our case, high, namely turn on the lamp. Otherwise, if it toggled the pin state to a 0, well, turn that pin state back to low. And it'll run over and over and over every time. And then when it reaches the end of void loop, it's going to come back up, read the analog value, and see if it's exceeding the threshold again. And as long as it's not exceeding the threshold, it's going to it'll keep the Arduino in whatever state, in the control pin in whatever setting it was at the end of void loop. If we turned on the lamp at this point, well, it's not going to turn off until another event occurs where our analog value that's being constantly read, this line will be read over and over and over again and implemented or executed in the code. But until the value actually exceeds the threshold, it's going to remain in whatever it was last set at. The time it actually made it through, the threshold was exceeded, it either turned that control pin high or it turned it low, and it'll stay there until the next event. So we snap our fingers, that exceeds the threshold, it flips our control pin state, assume it was in a 0 state at first, it turns it to a 1 state, that turns our lamp on. Then the next time around, our analog value hasn't been exceeded, so it's just reading that value, reading that value. Then all of a sudden, say we snap our fingers again, it exceeds the threshold. The last time through, this was at a 1. Now this will convert it to a 0. Then it will hit the if and the else. It's not if, so it fails, and it'll go to the default else, and it'll turn the pin to low, turning our lamp off. That's all there is to it. Now, how do we find the threshold? Well, all you have to do is you can upload this code once you've typed it in. And assuming it's been typed in correctly, you'll want to make sure before you upload it, I didn't, but you'll need to make sure that you're connected to the board type is correct. If you're using an Uno, a Mega, a Pro Mini, etc., just make sure to set the board correctly, and then the serial port, whatever serial port your Arduino is connected to, you want to set that, upload your code, and then you can open your serial monitor and see what the values are. In this case, notice that the ambient sound when I'm not talking is around a 7 or an 8. Then when I am talking, it jumps up into the teens and 20s. What happens when I snap my fingers though? And we can do that again. Okay, so now we can stop auto scroll and scroll back and scroll up and see that the snap of my fingers close to the sound detector registered to 232, which is more than enough to exceed the threshold of 100. And we can scroll back. I snapped previously, it was a 258. That was more than enough to go over the 100. And in this case, it was just a 166, but that was still enough to overcome that 100 threshold. And what you'll want to do is you'll want to test this. Move further away and get closer to the sound detector and snap your fingers, clap your hands, and find out what values you get. So if I snap my fingers kind of at a distance, not loud enough, there's loud enough, you can clap your hands. And we can go back and look at those values. There's a 189 with the hand clap, which is plenty, far enough above that it will trigger the 100 threshold. It'll exceed it. And then the snaps of the fingers, I tried to snap it at a pretty good distance away one time. I don't see that, but it doesn't really matter. In this case, the snap was at 129. And then there was one more snap that I did. There's 135. This is the reason that I just experimented with it and noticed that these 100 values were occurring sometimes when I snap my fingers. And I said, well, every snap always exceeds at least 100. I could have gone with an 80 or a 60. That would make the detector more sensitive. But based on, first off, what is the ambient analog value in your environment based off of your sound detector board? That's the first thing you want to find out. Mine, this is a pretty good board. It's almost at 0 when no sound is occurring. It's just 7s and 8s. Then when I talk, this is like background noise of talking. It's in the teens and 20s. So a snap of the fingers always tends to exceed a 100. And that's why I picked a 100 as my threshold value. Your values, your initial values may be teens and 20s just in the ambient environment, depending on how sensitive your particular sound detector board is. And you'll need to adjust your threshold value to compensate. Just have the analog values running, auto scrolling, snap your fingers, and see what the trigger value, see what the value was during that snap event. Then just go a little bit below that. Find the quietest snap, like there's a 110. There's the 231. And that's all you have to do is just play with it and see what your values are. Like 231, plenty far above the 100 mark. But the really quiet snap was only a 110, so it just did clear that threshold. And you'll notice it as you play with it, what value you need to put for this particular variable, that threshold variable. And if you put it too low, it's going to trigger when you don't want it to, like people talking loudly in a room. If you put it too high, you'll have to really make a loud noise to ever overcome that threshold. And it'll be relative to how close or far away you are from the sound detector, as well as what direction do you have the microphone on the sound detector pointing. Notice that electronic microphones, they're not omnidirectional, they're unidirectional, that you need to make whatever the noise is facing the microphone, not trying to do it behind the microphone. If it's facing away from you, that will make a lot of difference in what value is actually read through that analog read. And once you've got your threshold set, you can go back in, because there's no need to have the serial pins on the Arduino just constantly sending these serial prints. There's no need for that. You can just comment out everywhere in this code example where it has serial prints. As well as you can take this half-second delay out. You need to keep this one in. but you can take the one out. I just put that in so that it's easier to see through a video, and it'll be easier for you to see as you're trying to determine what you need to set your threshold to. But we can display this code one more time so everyone can see it. There's the global variables. You can just pause the video and copy it if you need to. There's the void setup. And if I'm good, we can get all of this on the same screen. There's void loop. Move the cursor out of the way. And you should be able to enter this code and upload it to the circuit we just built. Now let's see, how does it work? We'll plug in our extension cord, we'll plug in our lamp, and see what it looks like.
We have our lamp plugged in to our extension cord, and our Arduino connected, the solid state relay connected to our breadboard with our Arduino and our sound detector. What we'll need to do is just plug in the power supply for the Arduino, and then at this point, notice the extension cord has not been plugged in yet. We'll plug it in, and until we make a sound that exceeds that 100 threshold, the lamp will stay off. But if we snap our fingers, the lamp comes on. Snap them again, and it goes off. We could clap our hands. Turn it off. And that's all there is to it. At this point, there's electricity running through the back side of that solid state relay. So don't make any modifications. You don't want to touch any of this stuff until you've unplugged it out of the wall. Basically, you don't mess with anything to do with a circuit that's controlling an AC device until you're looking at the plug-in. And I hope this video has been helpful. If you liked it, please click like and consider subscribing to my channel. Until next time.